if you remember, we did 3.7 day 1. And this is actually the same thing, okay? Some of them are even easier than yesterday because we're really using two forms of graphing. Yesterday we did standard form, where you had to do the negative b over 2a, and then you went to the chart on the table of values in your calculator. And today we're going to do vertex form. And in the homework, there's some of both. So if you weren't here yesterday, you're going to get practice on what we did yesterday. Okay? So just a couple reminders, Paris. Couple reminders. Albert I.O. is due every Monday at midnight. So if you didn't do it last night, you can still do it for up to 1 week, up until next Monday, for half credit, okay? There's always time in class after the homework. You should make sure you get it done. There's a new one now, because yesterday was Monday, and it's due next Monday, okay? So just stay on top of it. We've talked about it a million times. Also, for those of you that missed the 3.3 quiz that we had 2 weeks ago, or the 3.6 quiz we had Friday, if you're not sure, check Focus. Everything's graded, okay? So if you missed either of those quizzes, they're due by Friday. Don't wait till Friday, because if you're absent on Friday, it just becomes a dropped quiz, a 0, and it gets dropped. But if you want to make it up, it has to be done by Friday. So if you are missing one of the 2 quizzes, please see me and schedule that. Once Friday passes, I'm going to give that 3.6 quiz back to you, because they were not great, and we need to see what we did wrong, okay? Because 3.6 was quadratic formula and discriminant. That's coming back. We have to know how to do that. Okay? We're going to have a test eventually. Okay, enough. Vertex form looks like this. It's easy to recognize. It's got the parentheses. Remember, standard form was ax squared plus bx plus c. Okay, that's standard form, no parentheses. Vertex form is actually easier to work with, because you don't have to do that negative b over 2a formula. You don't have to do anything. You have to be able to identify h and k. So it's this number and this number. What do you have to remember about the h value? Opposite. That negative there means change the sign. Okay, so we'll see that in a second. And then we learned yesterday that if there's a less than or a greater than symbol, that's dotted when we graph it. And if it has the equal to symbol, we make it solid. Okay, and we've seen that before with other types of graphs. That's nothing really new. And since these are inequalities, right, we have inequality symbols, there's shading involved. When it's an equal sign, it's just those points. That's it. But we're saying all the numbers less than that parabola or above, greater than that parabola. So we learned yesterday that if we see one of these symbols, we shade below. And if we see one of these symbols, we shade above. So what's great about this section is we're reviewing section 3.1 and 3.2, because that's when we just learned how to graph. And we're just throwing a little bit of extra on top of it, okay? So here's our first example. And when we get to the homework, if you want graph paper, remind me, because I'll forget, and I'll happily share my graph paper with you, okay? In the notes, we don't have to waste graph paper if we don't want to. Okay, so guys, first thing you should recognize is that this is in vertex form, right? VF, vertex form. So I say, oh good, I don't have to do that negative b over 2a business. I can just identify the vertex by the h and the k. And like a lot of you told me, we do the opposite of that one, but not the opposite of that one. So -1, we think of positive. Positive 3 is positive. Everything okay? What's going on? What? A what? A lizard. Okay, a lizard. Okay, you guys know I have a complete phobia of a certain creepy crawly. Like I'd start crying if it was something else. I'm afraid to tell you what it is, because I'm afraid you guys will use it against me. I mean, nobody likes a spider, but oh, okay. I don't care for spiders, but my absolute phobia is cockroaches. I'm destroyed by the sighting of one. So let me tell you something. I give you grades, okay? And I'm recording this. It's on record. I will always win in the end, okay? So here's the thing. I have such a bad fear of them. Over the years, I've shared with my students all the major story of something that happened that I will tell you if you want to know in a minute. But and I've had students like try to like play tricks on me. There was this student named Leighton Ayers. I'll never forget him. He thought it'd be funny to go to Miss Shackton. Miss Shackton like gets really into Halloween, and she decorates her room, and she had fake spiders and fake cockroaches decorated. And he said, "Miss Shackton, can I borrow one of these?" And she was like, "Yeah, okay." So what he did was I was standing at the door with my sweet self saying, "Good morning, hi, how are you?" And Leighton came in, and he opened my teacher's edition, and he put the fake roach in my book, like this. So when I opened it, I saw it. Now, I'm an intelligent human being. I knew it was fake. I could tell it was plastic. That doesn't matter for my brain, so I immediately start sobbing. I do. And, all my mascara running down my face. I feel like they're crawling on me. My hair gets tied up in a knot. I'm, like, in the hallway, and I'm, like, hyperventilating. And the teacher who was across the hall from me then, I was in a different classroom, came out and he's like, "Oh, my God, something happened to Riley or Tony," which are my kids. And I was like, no, it's just a fake roach in my room. So there's a reason why, and I'm going to tell you the story after the notes, so if you don't want to listen to me, you can ignore me, but it's actually a good story. But let me just show you something. I'm so afraid of them that this one student of mine last year created a evacuation route. Okay? So this is C-Wing. Miss Shackton's across the hall. Mr. Kadelich is there, and that's the computer lab. So I used to tell my students, on all seriousness, especially when I had a yucky carpet, I used to tell them, guys, if you see a roach in my room, and that's why I was panicking like that, if you see one in my room, you need to assess the situation. So Shane is sitting in front of me. He sees a roach like on the wall right here. He has to say to me, "Tracy," because he won't call me Miss Morse, because that, everyone's like, "Miss Morse," gets my attention if you call me by my first name. Go out this door, right? If it was by this part of my classroom, Shane would say, "Okay, where's the safest place? Miss Tracy, go into the computer lab." So you give me, I have 3 escape routes, and then somebody has to kill it, and then I can be okay. And so someone came up with this for me. It's a serious thing. Please don't play a joke on me. It's really mean. I'm actually a little bit better as I get older. Like, I won't probably start crying. You won't get that reaction out of me. But, like, my heart is beating really fast just from what Richard said, because I couldn't tell what he was saying was there. It's a lizard? Okay. Is anybody scared right now? You okay? I'm okay. All right. Let's do this. All right. And I'll come back to the why. You guys, you want to hear this story, for real. Okay. Once you have the vertex, we go to our calculator, and we grab 2 more values. Okay? So clear your RAM. The pre-calc kids have been doing some crazy stuff. And we just type it in. Okay? Just like we did yesterday. So I have -2, parentheses, x minus 1 to the power of 2, come back down, plus 3. So just like we've done a million times, guys, we type it in. Then where do I go? Table. You can graph it if you want, but we don't really need the graph. The graph isn't going to give me the points. We go to table. And so find your vertex. It's 1, 3. There it is. Okay? And then pick 2 numbers on either side, just like we did yesterday, but we had more work to do. 2, a 1, and a -5. Okay. Now we're ready to graph. That's it. So let's get off our phones and graph. Okay, so start with your vertex, right 1, up 3. There's my vertex. To the right 2, up 1. To the right 3, down 1, 2, 3, 4, 5. It's opening down, which makes sense because it's a negative A value. And we can just use that axis of symmetry to reflect off across it to see the other half of our parabola. Now, this is a solid graph, right, because it's got the equal to sign. If it didn't, I would put dotted. If I accidentally made a solid line when it's supposed to be dotted, remember how we did it yesterday? Just write me a little note, dotted with an arrow, meaning you meant to make it dotted. But this one is solid, okay? And the last thing, which is really the only new part of this, is less than. We have to decide if we're going to be on the outside of the parabola or on the inside for less than. And it is inside. Okay, as we're going down, think about how we can get lower and lower and lower. It's just in between. So less than, when it's opening down, is in between. And it goes on forever. I'm just stopping right there, right? As the arrows go down forever, so do all of our ordered pairs that would make this true. Okay? Let's just do one more, and then I'll start your homework with you. The minute I see those, the minute I see those parentheses, guys, I go, this is vertex form. That's how you tell the difference from the ones we did yesterday to today. These are our favorites. These are the easier ones. We don't have to do negative b over 2a. We can just identify our vertex. H is the number in the parentheses, and we do the opposite. So plus 1, we think negative 1. Wait a second, where's our k? What? Yeah, right? We don't put plus 0. If it's not there, it's a 0. Okay? And then we go to our table and pick 2 numbers on either side of negative 1. So you can either clear the RAM or just hit y equals and then hit clear and it just takes it out. Okay? And then type that in. 1 divided by 3, that's 1/3, right? 1/3, parentheses, x plus 1 to the power of 2. And you can graph it if you want, but it's not going to give us anything. It's just going to tell us if our graph is right in the end. We want to go to the points. So I need to find where my vertex is. I'm going to scroll backwards. There it is, negative 1, 0. And you can really pick any numbers you want, okay? But let's just stick with picking numbers really close to it, like 0 and 1. Who cares that they're decimals? It just makes it kind of annoying to graph. But it's not exact, it's not perfect, it's okay though, all right? So, my vertex is negative 1, 0, that would be right there. And then 0.3, okay, maybe right there. 1, 1.3, right there. And then just go across your axis of symmetry. Here. This one would be dotted. So if you accidentally made it solid, just write me like on a test or something, you'd want to make sure I know you meant to make it dotted. That's all you have to do, no big deal. Greater than, we want greater than. Is that going to be inside or all around the outside? I know what's making you pause, because this one is less than and we said inside, but it's opening down. You want greater than, that's going to be these numbers going on forever. Think about it. If I went down here, that's below the graph. This would be less than if I went up here. Okay? This would be greater than. That's the only part I worry about you guys messing up on. Okay? Do we get it from yesterday? Were we getting them right yesterday? Say it again, Raza. Okay, because it's greater than. We want all the points above it. So you have 2 choices. It's either up here or down here, along with all the space on the side. Which one is more above? Right? Above this graph, greater than would be these points. This would be less than. Look at the last one we did. We either have below the graph, which is in between, that's less than, or above the graph, including some other spots. But if you just look at it like that, which one of those sets of points are below this graph or less than? These are going above the graph, right? Think about where are all the points above that graph, up here. So we don't want those points. These points. Okay, yeah, sometimes, if this had been a greater than problem, this same graph right here, if it had said greater than or equal to, then I would have shaded on the outside. But since it's less than, I shaded on the inside. All right, let's do some of the homework problems together, and then hopefully I can make that more understandable to you. Graph paper. Okay. Graph paper, anybody? Okay. So guys, look. Right off the bat, number 6, write it down. We've got a problem. Not a major problem, okay? But notice y is on the other side. If this was an equation with an equal sign, who cares? It doesn't matter. But you've got to be careful if they put the y on the other side in an inequality, okay? So I like to rewrite it in the other direction. I want the y over here and then all the other stuff on the other side. What you have to be careful of is which way you do this. So I think of it as like a pointer. Like this symbol is pointing at y. It still has to point at y when you reverse it. Okay, see how it's pointing to it here? It's still pointing to it. So you always read this from like the y. Y is less than, y is less than. Do you have to rewrite it like this? No, you don't. You don't have to, but it just makes it easier to read it, right? So now that we have it in the right order, we can say the vertex is 6, 0, right? Then we can go to our calculator and get a couple more points. So we go to y equals, clear it out, negative parentheses x minus 6 to the power of 2. Right? Just typing that in. Go to our table, and we want to find 6. So scroll till you get to 6. Okay, so now you can see there's my 6, 0. I'm going to go back. I'm going to use 4, but you could have used 7 and 8. I'm going to use 4 and 5. It doesn't matter as long as it's 2 on either side. Okay? So you either have 4 and 5 with these y values, or you have 7 and 8 with these same y values. Okay? All right. So I'm going to be skewed quite a bit to the right. Oh, this is vertex form, by the way. All right, so let's go ahead and plot the points. So my vertex is at 1, 2, 3, 4, 5, 6, 0. There's my vertex. Then 1, 2, 3, 4, 1, 2, 3, 4, and 5, negative 1. Sorry, I already have the key made below here, so I'm trying to cover it up. There and there. Dotted. Okay, so that's dotted. And then, so let's talk about this. Dotted, because there's no equal to sign, and this is less than. So when we're pointing down, is less than going to be in between or out on the outside? So Raja, do you see that? Less than here would be like in here. Think about below the vertex. That might be a way of thinking about it. Less than would be where are the points below the vertex. If it was greater than, we'd be on the outside, out here. And that's the end of the problem. For which, the second one that I did? Is that what you're saying? Because now we're up. Think about the points that are above the vertex, greater than. So you can't say inside is always like less than. Inside could be greater than or less than, depending on which direction we're going. Where are the numbers that are greater than the vertex? Let's think of it like that. Are these points greater than the vertex, or are these points greater than the vertex? It's these points. Okay? Back to this one. Where are the points that are less than your vertex? Here's my vertex. Those are the numbers below it, right here. You still having trouble seeing it? I'll come help you. Okay. Where am I? All right. Here's another one. This is also vertex form. We love these. These are our favorite types. Calculator does everything for us. We just have to remember negative opposite sign, not opposite. Okay? Typing it in. We should be getting really good at typing these in our calculator. X plus 3 in parentheses squared minus 2. Table. We want to go to where our vertex is. There it is. And pull some more points off. Two is enough. All of our points are in quadrant 3, left and down. So I'm using limited space is why I keep talking about that. So it's a way of fitting a lot of graphs on one sheet of paper. Left 3, down 2. Left 2, down 1. Left 1, up 2. So 1 point's in that quadrant. Dotted or solid? Dotted. And greater than is above your vertex. Above the vertex or below. That's a nice way of explaining that. Okay. I left you 3 problems to do. 3. Okay. Some of them are in standard form, like number 8 and 15. That's a review of what we did yesterday. Remember, we pulled out the A, the B, and the C and did all that. So I'm going to come around and help you guys. If you weren't here yesterday and you understand 8 and 15, you're great. You're in good shape. If not, you might need to go back and watch the video for that, or notes, or ask for help. 6 through 9, 15. They're all right here. 6, 7, 8, 9, 15. You just number it wrong? Maybe you just numbered it wrong. Guys, can I tell you my roach story? No. I'm telling you, it's worth hearing. It is not